Okay. There are three things that I wanted to talk about. So let me share the screen here. One is the Liskov substitution principle. The second one is the stable dependency principle. And the third thing that I want to talk about is the design pattern called composite. Okay, so let's first talk about the Liskov substitution principle. And you know that it is abbreviated LSP. What is it about? It is about whether you can create a subclass of another class, obviously. So if you are given a class X, is it okay to make a subclass of it called Y? Obviously, X will have some methods and some fields and all that. Then the question is does it make sense for Y to be a subclass of X? Of course, there are obvious things that you will never do. I mean, if you have a book class in the library, you will not make member a subclass. I mean, that is obvious. There is absolutely no relationship between these from a conceptual viewpoint. Of course, there are those entity relationships in the sense members borrow books, but that is not what we are talking about. Is there something that makes a member look like a book? That is obviously not there. So you can't do that. This is absolute nonsense, and nobody will do that. But it is not always clear what is okay. So, for example, is it okay to do something like a queue as a superclass and a stack as a subclass? Again, this is not appropriate because a queue has first in, first out property, whereas a stack is a last in, first out property. So they don't really have the same kind of specification. So that is also not okay. But some trickier ones would be things like you have a rectangle and then a square. Can you make a square a subclass of rectangle? A square is a special type of rectangle, but it turns out that if you have certain types of methods in square, then this is not always okay. So LSP is essentially a way of coming up with a criterion to say whether a certain type is a subtype of something else, whether a square can be a rectangle, whether a square could be a subclass of rectangle. This is the kind of questions that LSP tries to answer. This was proposed by Barbara Liskov of MIT, and she came up with this idea, I think, around 1996. Liskov. Yeah, so it is Liskov substitution principle. She gave a keynote talk maybe 25 years ago at Object-Oriented Programming Languages and Systems. And she just came up with this idea saying we should have some kind of relationship. And she came up with some criterion, which was not well defined. And then she and one of her students came up with a paper in 1998. I don't remember the exact year. And there they formalized the notion. And so there is a paper by Liskov and I think Wing. I think the other person is Wing. And that paper is the hardest paper that I have ever read. I don't claim that I have understood every bit of that paper, and I don't think there are many people in the world who have understood all of it. There would be quite a few, I mean, who are in the programming language theory world, but most people, I don't think, have understood the paper properly. It's extremely hard to understand. But I will say a few words about what the whole idea is. And before I get into that, let me tell you that professionals, IT professionals are fond of, to some extent, talking about LSP. And I don't think they quite understand exactly what LSP is, but they would probably ask you a question when you go for an interview. And so that is something you should probably expect. What is LSP? You should be prepared with a good answer that can convince them that you have understood the basic idea. The basic idea is not very difficult to understand, but some of the theory is quite hard. So let's see what the basic idea is. The basic idea is this. Suppose we made, let's try to be concrete here. Let's say we created a class called rectangle. So a rectangle has a length and a width and whatever. And then we created a subclass of it called square. Okay. So there are several methods in rectangle. You could think of things like get the length, get the width, set the length, set the width. You could think of getting the area or computing the area. You could have methods to compute the perimeter, etc., etc. Similarly, you can have methods in square. Now, you expect certain functionality out of all these methods, right? Now let's imagine a client. Client meaning somebody who is using these two classes. So there is a client here. What does the client do? It has methods that use both of these classes, perhaps. And let's pretend that it is in some method here, say void m, it gets a rectangle reference. And it has some code here. So this method is getting a rectangle object. That is the declared type. This is declared. R is declared to be a rectangle. And it uses R to do some work. Maybe this rectangle is a property, a lot, and you want to do something with that rectangle. And or you might get lots of rectangles. You are probably going to put those in a collection, some such thing. So let's assume that it uses methods of rectangle, r dot, compute area, etc., etc. So obviously it will use methods of R. It is not quite important what is happening here, what is important is to recognize that we are using the rectangle here. Okay, so we can pass lots of rectangular objects and you expect certain behavior. Now, this is what, this is roughly along the lines of how Barbara Liskov proposed LSP. Okay, she didn't use the specific example, but this is the idea. Now, suppose you get, instead of a rectangle, you get a square. You can pass a square, right? You can call M and then pass a square. You know that every square object is of type rectangle. So an R can be having the actual type of a square. So when you are actually executing the code, you are using a square, right? So when you compute the area, you are actually using the squares area. You're computing the squares area, not the actual type is not rectangle. Okay, if that is the case, is this behaving like it is getting a rectangle, or can you notice a difference? What do we mean? That is a very tricky question. I mean, the question is this: would that behavior occur? You see some behavior here. Would that behavior occur if there was, for some rectangle at least, you passed in a square and it did certain things? Is that possible with some rectangle object? If that is possible, if there exists a rectangle object that makes this method behave like what it did with a square, then this is okay. I mean, it is behaving like a rectangle because there is some rectangle for which it is going to produce similar behavior. So in that sense, the client doesn't notice any difference between a rectangle and a square. So everything depends on the kinds of methods you have in square and rectangle and how the code is, what the specifications are. So it is all dependent on that. I mean, so whether there is a rectangle that would be equivalent to a square to produce the same kind of behavior. If for every square that you pass, you can find at least one rectangle, then that will produce the same behavior, then this hierarchy is okay as per LSP. That was the original idea that she gave in a speech. Then I think she realized it had to be put in in a more precise form, and she came up with that paper. And for that paper, what they did was this: they simply looked at classes and their specifications, and they looked at methods and properties and came up with a theory that allows us to look at the signatures of methods, the properties, etc., the execution hierarchy. I mean, the kinds of executions that can be produced, etc., and then say whether the same idea can be what do you call, whether that idea that we just talked about can be derived, whether we can talk about whether a client would notice any difference by simply looking at all the properties of these two classes. And that is the real hard theory. Okay. So we have this kind of thing applied in Java, for example. In Java, some of the things that came from LSP is things like this. Suppose in the superclass we have public, let's say we have a return type of X, do something, and we are passing a Y. I'm writing this in Java, obviously. And if you have a method in the subclass that overrides this, so if you put at override, what can you put here? If this is Y, anything that is a super type of Y is acceptable as far as LSP is concerned. So if you put a Z here, and if Z is Y or a super type of Y, that is a super class of Y, then LSP is okay because you are not restricting the behavior. If this takes a Y, this will also take a Y, but this will also take more things. So you wouldn't notice any difference. I mean, this would behave like the superclass, because anything that you feed to the superclass's M method would also be fed, can also be fed into the subclass's M method. But the return type, I'm running short of symbols here, should be either X or a subtype of X. If it returns something that is a super type of X, then you will notice that sometimes this M in the subclass is producing things that the superclass will never produce. So in that sense, this should be either X or subtype of X, subclass of X. Z should be Y or superclass of Y. That is as far as LSP is concerned. But in Java, though, they don't allow this. This has to be exactly Y. In Java, this has to be exactly Y, whereas this can be exactly as in the Liskov substitution principle. So this is only one of the many things that the paper talks about. The kinds of the signatures that you have in the two classes. All the parameters should be having super types, and the return type should be a subtype. That is one of the several things that you have in that paper. And that is restricted in Java, as I said. In Java, they don't allow anything that is a super type. So they're following LSP here, but they have made one more restriction as far as the parameter type is concerned. And I'm not exactly sure why they don't allow anything that is a super type of Y. I've tried to Google that, but I haven't found an answer. I don't think they have spelled out the reason. So if somebody asks you what LSP is, what you should say is this: LSP is a way of specifying or determining whether a certain class can be a subclass of another class. So can Y be a subclass of X? For every possible client, would the client behave the same if X is replaced by Y? Okay, and think of some examples like rectangle and square. It depends on what you have in the two classes, what the methods are supposed to do. It is not immediately clear. You have to look at the specifications of the methods, what the post conditions are, what the preconditions are, etc., etc. So it is not an easy thing to determine. Sometimes you can easily say that something cannot be a subclass of another, right? But sometimes you have to look at a little more deeply. Okay, any questions? Okay. The second thing is the stable dependency principle. There are, this principle again came around the time that LSP was suggested, and it has several forms. Depending upon the person you talk to, they will say slightly different things. They have slightly different viewpoints. When it came, object-oriented programming was a little more novel than it is right now. And people were excited by the idea of classes and interfaces, right? And every class is actually an implementation, whereas an interface is a specification. A specification is going to be stable because you don't have any implementation in the first place, so there is nothing to change, and you don't really change an interface anyway. So interfaces are considered more stable than classes. So it is better if your design and implementation is going to be using interfaces rather than classes to the extent possible. For example, you would write list, my list equals new array list. A simple example, right? That is, you use the interface list as the declared type of the reference my list, not array list, so that you can easily change the implementation to something that is implementing list if you want it. So that is a very simple way of making something dependent on a more stable thing like an interface rather than an implementation which is less stable, in this case, array list. But we have come a long way over the past 25 years when this idea came. Everybody knows classes are less stable than interfaces. So people have tried to give more meaning to the this term, stable dependency principle. So what is dependency? So I have tried to give some ideas in the videos. If you have a class that class X, and if it uses a field Y, where Y is some other class, then of course X is dependent on Y because you're using Y here. So if Y changes, you could be affected here, right? So the stability of X will not be more than that of Y. If Y is unstable, X is going to be unstable, somewhat loosely speaking. So one idea, as I mentioned in the videos, is to relate packages. That is, if you have a package P1 and a second package P2, and you have classes here, you have classes over here, you could have some classes here depend upon classes over here. So depending upon how many classes you are having, you're making P1 dependent on, then you can compute stabilities and so on. That was proposed by a person named Martin. And I have given a little table. So let me spend a couple of minutes on that. Let me go ahead and share it. Okay. Yeah, I think this is the one that, yeah, what I have done was, what I have done here is actually look at all the packages of the drawing program. So every package is listed here, the application packages, and every package is listed here as well. And then if a class here is using a class in some other package, then I have put a number here. For example, the let's look here. Um, the package controller is depending upon one class in controller.commands. Then so similarly, you can interpret all these. There is one thing here, though, I have changed. This was produced last semester, and since then I changed this. Controller.states is dependent upon GUI.view.views, but I discovered this, I realized that this was a bad dependency and I deleted this dependency. So controller.states doesn't have any more dependency on GUI.view.views. This came because, this is all logical stuff and we don't want it to be tied to a JavaFX class. So this dependency has been eliminated. So the design is a little more improved in the version that I have put out this semester. And there are similar numbers you can derive from this. You can see in this. Okay. And in Java, they have now, I use this idea of dependencies in dividing up Java programs into modules. When you create a Java project, Eclipse asks you, do you want to create a module? And I said, don't use modules. If you use modules, you can actually say which module is dependent upon what, etc., which module requires some other module to function, and so on. So the idea of dependencies is there in that. Okay, so that is a summary of the idea of dependencies. Any questions? Okay. Now, I want to talk about one more thing. Here. And that is the composite pattern. Let me get ready for that. Yeah, I think I should be able to do it with this one. Okay, what is the idea behind composite patterns? I talked about this in the lecture, but let's spend a few minutes on this. I have this word window opened, and let me draw a few shapes. So I'm drawing a shape here. And I suppose I should be able to move this around, right? And then suppose I drew more shapes. Maybe one more. So I have three shapes now on the screen. And I can individually move them and I can individually delete them. But I could also, let me try here, select all of them and then move them together, right? Or even more interestingly, I can right click them and then say, I don't know if you can see this, but I have said group and pressed group. So the whole thing is now a group. And if I save this document, they will go together, right? I can also, I mean, so the whole thing is a group now. I can ungroup that by right clicking and selecting group and then ungroup from it so that they are now back to their individual. So I can do all this using the composite pattern. What I would like to do is make the behavior of a collection of things similar to that of an individual thing. So here the thing is shape. So the behavior of a collection of shapes is very similar to that of an individual shape. And for that, what you have is actually a composite class that is a subclass of the shape. And then you have a collection inside the composite. So it is a very useful design pattern to do kinds of things like this. I haven't, I don't have an easy to understand implementation of it for the drawing program. I'm planning to do that over the summer. Okay. So this is a very popular design pattern, the composite. Okay. You should have a sense of what it is for the exam. We didn't get into the details of this, unlike some other things like bridge or state or observer and all that. But you should have a sense of this for the exam. Any questions before we go further? Yeah, right. There was a question about LSP and stable dependency principles. Yeah, I don't remember the exact year when she proposed it. It was definitely before the days of Java. So Java, the designers of Java would have been influenced by it. In fact, when I first learned Java, I was quite excited because Java had lots of things that I had read in the read or studied in computer science theory, and they had actually implementations of it in the language. For example, there are these red-black trees that you study in computer science, and they had actually implemented it in the Java development kit. They had merge sort implemented, and they had the idea of monitors implemented. Monitors are used in, it's a theory in operating systems, and they had it implemented as in the synchronized concept. There is a synchronized reserved word, right? So all those things came from computer science theory. The people who designed Java, they were, I think James Gosling was a graduate of, as a PhD from Carnegie Mellon, and so he's pretty smart and knows computer science theory, and they actually put the theory that they learned in school to practice, and we are reaping the benefits of it through this language. So I'm sure that LSP was instrumental in their defining what overriding means in Java. So Nathan had that question here. Any other questions before we go to the topic of exam next week? Okay. The exam next week is going to be covering stuff from the state, the finite state machine that we talked about in relationship with the microwave. So the state pattern, the observer pattern, the way of designing and implementing things with as few conditionals as possible, then the MVC pattern, the bridge and command patterns, and undo, redo, and the stuff from this week, like LSP, stable dependencies, and all that. There will be 3 questions that are long. I mean, we had 2 long questions for the first 2 exams. This time we will have 3. One of them will be to implement a new shape in the drawing program. And you will have to do it without imagining, without assuming that there is any other specific shape implemented. So for example, if you have to implement a triangle, don't assume that a line has been implemented. Okay, you can copy and paste the code from line, that is fine. And I would suggest that you do too, but it has to be, it cannot be using the line command in any way. As one example, I don't know how you will do it, but if you find a way, don't do it. It should have all the, it should behave exactly like, or the interface should be like what it is for existing shapes. So there should be a button for the new shape. It should be possible to save the shape along with the other shapes. It should be possible to retrieve the shape along with other shapes. It should be possible to undo and redo the creation and deletion of those things. So what you should do is, and the design should be, and the implementation should be very similar to what is in the current version. So you cannot have a totally different way of doing things. Then you will lose points. That will be one question. A second question will be to take an implementation of a finite state machine and then fill in some missing code or wrong code so that it behaves as specified in the problem. So you won't have to write an entire program. What you will have to do is probably write a couple of methods, or I don't know exactly. I mean, few methods, modify a few lines, that kind of stuff. That would be the second problem. The third problem would be to take a specification of a problem, analyze it, and produce the state transition table for it. Okay, that would be the 3 problems. And there will be roughly 10 multiple choice or true, false, those kinds of questions.
How do you want us to turn in the transition table?
You create a Word document, and you can easily create a table there and then write it out. You can submit the Word document or the PDF. PDF is preferred so that if it is Word, it is modifiable and something can, I mean, when you save in a PDF, you know that it is stable. That is the reason I would like a PDF.
All right, thanks.
Okay, thanks. Any other questions? So it will be for 3 hours, starting at 6 and then around 6 and then ending at 9-ish. Okay. All right, then let me see if there are any more questions here. If not, let me stop recording. I haven't uploaded the last class recording, so I'll do that maybe tomorrow.